subscribe.
Hey y'all, welcome back. Tonight we're working on these quadratic themed CLEP prep test items. So we are just practicing problems similar to the ones we went over in class and that are similar to the ones that you'll see on the actual CLEP exam. So this first one says the graph of a function g is a transformation of the graph of the function f. They're both labeled here, and actually the function f, they actually give you the equation here is negative 1/2 x, and it says which of the following is the equation of g. So if you notice, g is not any wider or narrower than the original function f, so we know that the a value should be negative 1/2. And we can see on all the answer choices it's negative 1/2, so that's not really going to affect how we answer this question. The only other transformation that's occurring here, or really the only one, I should say, there's no other ones, is that it's being translated 2 to the right and 3 up. And so since it's going 2 to the right, we'll have an x minus 2, which we can see in choices B and C. Okay, so these are good. We can eliminate all the other choices so far. And then it's also being translated 3 units up. And so right here, that's we see that in choice B. When you have a plus, either plus or minus a constant on the end of your function, that's going to cause a vertical shift either up or down. So we also see that vertical shift in D, but that has the wrong horizontal shift. Remember that the horizontal shift is kind of backwards than what you might expect. If it says x minus on the inside of the parentheses here, that shifts it to the right 2 units. And if it says x plus, it's going to shift it to the left. So that's kind of counterintuitive, I think. So be careful about that. The vertical shift, I think, is exactly intuitive. If it says plus 3, it goes up 3. So our answer for number 1 is going to be B. For number 2, it's going to be a very similar problem here. Okay, it's basically the exact same thing, except it's not multiple choice, so you're going to be in charge of actually writing the function here. So we'll start off with g of x. Just like with the last one, the new function has the same width. You can see that, like, if I look at f of x, I go up 2 over 2 to get a point, and I can do that exact same pattern to get a point on g of x. So I know that it should be 1/2 as my vertical stretch. It should be the exact same as what the original function was. So it should be 1/2 times, and then let's see if we can figure out what the translation is on this one. This one's going 1 to the right, and then, what is that, 4 down. So it should be x, 1 to the right is going to be minus 1, okay, squared, it is a quadratic, and then minus 4. So this problem just tries to make you go one step further, instead of just like picking the one that's right, actually writing out the equation. The one that you'll see, though, on the quiz tomorrow and on the test will be multiple choice, just to alleviate your concerns a little bit. Number 3, trying to match the graphs to the description, and this all has to do with the discriminant and also the a value. So let's just break this down, okay? If the discriminant is positive, that means we're going to have 2 x-intercepts, okay? If it's negative, or let's just say if it's 0, let's start with that one, then there will be 1 x-intercept. If it's negative, then we're going to have 0 x-intercepts. So we'll be looking at the x-intercepts and just kind of counting them to determine what our correct answer is. Now, as far as the a value is concerned, that a value is the leading coefficient. Okay, so I'll just call it a, which is the leading coefficient. Now, if that's 0, we actually don't have a quadratic, so we don't need to really worry about that for this one. But if it is positive, that means that the parabola is going to open up. If it's negative, then that means the parabola opens down. Now, I don't think there's enough problems here to really get every single combination here, but we have 5 of them here. So the first one says the discriminant equals 0. Well, if the discriminant's 0, that means there's one x-intercept. And we can see there's only one choice here that has one x-intercept. That's right here on B. So the first one should be B. The second one says that the discriminant is negative. Okay, that means that there's going to be no x-intercepts. So that could be either C or D. But it also says that the A value is positive, which means that the parabola is going to open up. And so that locks us into saying that this answer is going to be C. The next one says that the discriminant is negative. So just like with the last one, there's going to be no x-intercepts. But for this one, the A value, or the leading coefficient, is also negative. And so that has to be D, because the D has no x-intercepts and it opens down. The next one says the discriminant is positive. So that means there's 2 x-intercepts. That could be A or it could be E. And the A value, the leading coefficient, is positive. So that means it's opening up, and that means it's got to be E. Now, just using process of elimination, we could probably figure out that the last one's going to be A, but let's just double check. It says the discriminant's positive, so we get 2 x-intercepts, and the A value is negative, so the parabola opens down. So, yep, A checks out. So our answer there is A. Number 4, it says if f of x is x squared plus 3, then what does f of x plus 4 equal? So this is just a simple transformation. And what you have to do is just plug in x plus 4 into x squared. Now, the only thing left to do after that is going to be to simplify this expression. We've kind of done, the most important step first. This is correct, but most likely the answer choices are going to be in standard form. So let's go ahead and multiply this out. X plus 4 squared is going to be x plus 4 times x plus 4. So when you multiply that out, you have to distribute each term in the first binomial to each term in the second binomial. So x times x is going to be x squared. X times 4 is going to be 4x. And we actually have that twice. And then plus 16. We have it twice because we have to multiply this x by this 4, but also this x by this 4. That's why we're getting the 4x twice. Then if we combine like terms, we are going to have x squared plus 8x, and then 16 plus 3 is going to be plus 19. So f of x plus 4 equals x squared plus 8x plus 19. Number 5 says, well, it basically is the exact same problem here. In fact, I'm just going to copy my work from number 4 just because it's essentially the same thing. Really, the only difference here is that I'm substituting in an x plus 5 instead of x plus 4 here. And the original function was x squared plus 4. So I'm going to change this 3 to a 4. But from there on out, like the steps we're going to take are going to be basically the same. I'm going to delete these numbers because, the actual numbers will be different, but the steps will be the same. So x times x is x squared. X times 5 is going to be 5x. And once again, we get that twice. 5 times 5 is 25, and then we have that 4 hanging out there. So f of x plus 5 is going to be x squared plus 10x plus 25, and 4 is going to be 29. That's your answer for number 5. Number 6, it says for each of the following, determine if the vertex of the graph is above, below, or on the x-axis. So the parent function y equals x squared has the vertex exactly on the x-axis. So what we're going to be thinking about, this is basically the graph of x squared here. So if we've got a transformation on that, we need to think about how that's going to transform the graph, and then does that actually put the vertex above or below the x-axis? Letter A says x plus 1 squared. Now what that does, and I'm actually going to make a note on each of these what the transformation does so that you can hopefully understand it a little bit better. But this one's going to shift to the left 1 unit. Okay, so shift left 1 unit. Now, if I move this graph over to the left 1 unit, that's not going to move the vertex off of the x-axis. It's just going to move left over, so it's actually going to be on the x-axis. Okay, so if I'm just simply doing a shift left or right, then my vertex will stay on the x-axis. Letter B has 2 transformations. The negative sign here is going to be reflection over the x-axis. So instead of opening up, it opens down. And then also there's a shift up 2 units. And it's that shift up 2 units that's going to cause the vertex to be above the x-axis. Letter C has just 1 transformation. It's a shift down 3 units. Okay, shift down 3 units. Let's move this over so we have a little bit more space here. Okay, so if you see this graph over here, let me kind of, can I pull this over a little bit maybe? Well, maybe not, but anyway, if I were to shift this down 3 units, the vertex, instead of being right at the origin, would be down here. So hopefully you can see why the vertex would be, in this case, below the x-axis. Part D has x squared plus 4. That's going to be a shift up 4 units. And so the vertex would be above the x-axis. Letter E says x minus 5 squared. That's going to be a shift to the right 5 units. And so since it's shifting to the right 5 units, the vertex will remain on the x-axis. It's going to let me type here. Come on. There we go. Letter F has 2 transformations. It's kind of similar to part B. It's got that reflection over the x-axis, but in this case we're shifting down 6 units. And so if we're going to shift down 6 units, that's going to put our vertex below the x-axis. Letter G is x squared plus 7. Whenever you're adding a constant like on C or D, that's going to cause a vertical shift either up or down. And since it's plus 7, that's going to be a shift up 7 units. And so this graph will be above, or well, yeah, actually I guess the whole graph, but specifically the vertex will be above the x-axis. And finally, we've got x squared minus 8, which is going to be very similar to C. It's going to be a shift down, but in this case 8 units. And so if we're going to shift that parabola down 8 units, then the function's vertex will be below the x-axis. All right. Number 7. It's our last problem. It's pretty short homework tonight, hopefully not too short. It says, the graph of the quadratic function is shown. Explain how you come up with each answer. So the first one says, how many real roots does the function have? Well, notice there's no x-intercepts. Okay, so how many real roots? 0. Okay, there are no x-intercepts. Okay, it says, is the leading coefficient positive or negative? And we can say, well, the leading coefficient has to be positive because the parabola is opening up. The domain of the function is going to be all the possible x values, and this is going to be true for all quadratic functions unless there's some external domain restriction, like if it says that x can't be negative for some reason, or maybe there's a real world, you're throwing a rocket, or you're throwing like a ball or something, or launching a rocket, and it has to hit the ground, so it can't go below the surface of the earth. There might be some context that prevents the domain from being all real numbers, but if we're just looking at a parabola, the domain is just going to be all real numbers. Is the range all real numbers? No, the range is not all real numbers because there's no points below the vertex. There are no points below the vertex. Remember that the range consists of all the y values that are represented on the function. And the y values, kind of start here. We don't have any numbers, but let's say it was like 1. Then in that case, the range would be all the y values greater than or equal to 1, but not less than, because there's no graph down here. All right, well, that about wraps it up for tonight's homework. Thanks for watching, and y'all have a great day.